So by the way, I read some of your comments on the questionnaire that I asked you to fill out. Thank you very much if you did fill that out. I think that one of the main themes was to do more examples that are kind of closer related to some of the homework. So I will absolutely take that into consideration. So hopefully today's class I'll do a few more examples that are very closely related to what we're doing. Another sort of main theme in terms of the requests for some changes was to dedicate a little more class time to doing work, so we can actually, do some work together, and I can give you some direct feedback because, it can be challenging to, work from home and all right, now we got everyone here. To work from home and then communicate with me. I know that there's been some questions about how the Discord works. A lot of students have been just emailing me, which is fine. Email works just great. I just find that it's a little bit slower than something like Discord. But whatever works best for you, I really want to make sure that however you prefer to communicate, that I can do my best to respect that. So yeah, but end of the day, the two things that I'm going to try to do going forward is to dedicate more time in class to actually working, so I can give you some direct feedback, and then also the examples that I work on in class are kind of more closely related to the examples that we'll be doing for homework. Another quick little announcement. I'm going to slightly change the source of our questions. I wasn't super satisfied with the questions that we were working on last time. This is the first time I've taught this course, so I've kind of been experimenting a little bit with different sources. I liked how that book started off, and I liked the topics that we did. But I found another book that I think you may like a little bit better. So I'll be providing copies of that book today. So yeah, and if you're not here today, then I will just post the section that we need for today's class. So we are going to continue on working with functions, sort of altering functions a little bit. So the thing that we were working on previously was combining functions. So we had sort of arithmetic combinations, so where we would add or subtract, multiply, divide different functions, and then we looked at the composition of functions. Today, what we're going to do is we are going to translate functions. So translating functions is kind of one of the more important things that we can do to functions. So translating a function really means like a vertical or a horizontal shift. So we're taking our function, right? So let me give you kind of a quick example here. So a vertical or a horizontal shift would look something like this. So let's say I have a nice little parabola. So let me just quickly draw a nice little parabola, and then we've got a parabola that looks like this. So let's say that our parabola is just the standard one. Oops, that doesn't look nice. A nice looking parabola like this. So here's our parabola. We have a vertex at 0, 0, a vertex at the origin. Okay, and let's say I want to move this parabola around. Okay, so then I would have a really similar looking graph. Okay, so we're just shifting this thing horizontally and vertically. So maybe now my vertex is sitting somewhere over here. So I've got that same parabola. Oops, I kind of got the autocorrect thing on. Okay, there we go. So I've got that same parabola. It's just been shifted a little bit to the right and a little bit to the upward direction. So you can kind of see what's going on here. So here's where my parabola started. There's where it ended off. So I moved this one, looks like about 3 units to the right and 1 unit up. So what I'd like to start off with is a Desmos activity. I'm still working on getting access to the Chromebooks. At this point, we are unable to use the Chromebooks because I need to clean them, and in order to clean them, I have to have access to chemicals. And in order to have access to chemicals, I need to have some certain training. So I'm still working on that training. So I'm unable to provide Chromebooks at this time, but hopefully sometime this week we'll have access to Chromebooks. So unfortunately, it's going to be a little less interactive than I would have liked. You're essentially just going to watch me sort of fiddle around with some of these functions. Okay. If you like, and if you have a smartphone, you're more than welcome to follow along on your smartphone. But Desmos is a little bit clunky on a smartphone. So what I'm going to do here is I'm going to start off just by putting in a function, and then our goal is going to be to sort of move that function around left, right, up, and down. Okay. Tomorrow, what we're going to try to working on is taking a function and stretching it vertically. Okay. And those are all the things that we can do with the function. We can move them around, like translate them up, down, left, and right. And we can also stretch them vertically. So that's kind of our goal for today. Are there any questions about any of this before I jump into this? No? Okay. Okay, so let's start off with a function. Let's call it f, and our function is going to be f of x. And let's say that that's equal to let's say I don't want to do like too simple of a function, because I think that a lot of us already know how to move some parabolas around. So let's try something a little more funky. Let's try something like the square root of x. Okay, so let's try the square root of x. So this is our function here. Let's see if we can move this function around left and right. Okay, so so let's think about, first of all, how we could move it up and down. Okay, so first of all, if we look at how this function works, what I do is I take my x value and I take the square root of my x value, and that returns my y value, right? That's how this works. So if I were to take the value, let's say 1, right? So the square root of 1 is equal to 1. So that tells me exactly what my y value is. Okay. So here's the square root of 1. The square root of 1 is equal to 1. So my y value is equal to 1. Okay. If I move over to 4, the square root of 4 is equal to 2, right? And then we've got all the numbers in between, all those funky kind of decimals. So the next one, of course, would be the next integer value would be 9 and 3, because the square root of 9 is 3, etc. So this is the square root of x. This is what the function looks like. It looks sort of like a parabola, right? It looks like half of a parabola is kind of on its side, right? So this is a function that we're going to try to move around. Any thoughts on how we could move this function 1 unit up? Yeah. Yeah, just add a constant at the end of it. Yeah, so if I were to let's say I'm going to call this g of x. If I was to take another function g of x, and if I were to just take f of x and add 1 to it, then I would have shifted that whole thing up by 1. Okay? And what I'll do actually is I'm going to add a slider a, and we'll be able to see that if I take my function f of x and I add a value to it, then I can just shift it up and down like that. Okay? So so that's how we would move it from going up and down. Our next goal is to try to move it left and right. Okay. So if I were to take one of these values and I wanted to move it to the left, right? Well, let's see if I could figure out a way of getting this point here 4, 2 and moving it over left by 1. Okay. Well, if I were to say, okay, how about instead of taking the square root of 2 here, what if I took the square root of 4 instead? Okay. So instead of at this value right here, instead of taking the square root of 2, if I were to take the square root of 4, so two numbers greater, then all of a sudden my point would be up here, right? So here's what I'll do. I'm going to make a new function h of x, which is going to be f of x plus 2. Okay. So basically what I've done is I've gone in here and I've said, okay, instead of taking the square root of x, take the square root of a number that's 2 bigger than x. Okay, and when I do that, well, look what happens at 2, right? When x is equal to 2, instead of taking the square root of 2, I'm taking the square root of 4, right? So I've basically just shifted the whole function over left by 2. Let's try another value just to be sure. I know that the square root of 9 is equal to 3. So if I go over to, oh yeah, over here. If I go over here to 7, I'm not taking the square root of 7 anymore. I'm taking the square root of 7 plus 2, right? So here I'm taking the square root of 7 plus 2, which is 9. So that's why I get a value of 3 here. So remember that the purple graph is the one that I shifted over. Okay? So that gives us 2 different tools here. I've got 2 different tools. I'm gonna sort of hide some of these other functions here. So if I want to shift shift our function, let me call this s of x because we're shifting x. Then what I can do is I can say, okay, I'm going to take my function f of x, and I'm going to add my vertical value. Okay, that's what I want to move vertically. And actually, I'm going to change that to a k because that's the value that we often use to represent a vertical shift is with the value k. And then if I want to move my value or my function around, well, I'm gonna sort of make a purposeful error here, and you'll see why in a second. You might think, okay, if I want to move it left and right, then I'm gonna add an h. So h is what I'm gonna do to to make a horizontal shift. Okay. So let's take a look at this. So here's where here's my sliders here. So if I want to move it up and down, I can add k to it, and that moves my function up and down. And let's see what happens with my k or my h value. My h value is my horizontal shift. My horizontal shift. But you'll notice that it's backwards. You'll notice that it's backwards. So if I want to shift over by a value of, let's say, 2, well, look at that. Now I've had to subtract 2, right? So remember what happened here is that if I wanted to figure out, like if I wanted to have this 0.42 now be over to the left, I had to find out what was happening further to the right and shift that over. So instead of instead of adding h, the trick here is actually to subtract h. So now I'm subtracting h. So that's how this works. So now this is how we would translate this function around the Cartesian plane here. So if I subtract like 3, let's say, and I add 3 to k, then that's what my new function is going to look like. So I can shift it around. Okay. So that's going to give us a couple of formulas here. So let's write some of those formulas down. Okay. So the idea looks something like this. So a horizontal shift. Let's start off with a vertical shift. Let's do a vertical shift. Okay. So to translate f of x vertically, we add a constant. So f of x plus k. So this shifts that shifts f of x up by k units. Okay, so we add it on the outside of the function. A horizontal shift is very similar. I keep forgetting my T's here. At least I'm not forgetting the F's. Okay, so to translate this horizontally, we do this. So to translate f of x horizontally, we add to the inside of the function. Actually, I should say we subtract. We subtract from the inside of the function. Okay, so we would write f of x minus h. So this translates, this shifts f of x h units to the right. Now keep in mind that we're subtracting h. So that's often an area of confusion. So just we have to keep our sights on this value h, and remember that we're subtracting it. So that means that if h is negative, then we'll be moving to the left. If h is positive, we'll be moving to the right. But since we're subtracting it, it's going to look a little bit different. So we have to ask ourselves, what are we subtracting from h? So as a combination, so let's kind of combine these. In summary, so let me just say in summary, f of x minus h plus k shifts f of x up by k units and right by h units. Okay? So another way of thinking about it is that if I want to change the point on the graph from x comma y. So if I have a point x comma y on my graph, so let's say that this is my point x comma y, and I want to shift that thing over. If I want to shift that thing over to x plus h and y plus k. So if I want to say, all right, maybe here's my graph. Here's where x comma y is, and I want to shift that thing h units to the right and k units up to this point over here, x plus h, y plus k. Then the function that is going to represent that will be the function f of x minus h plus k. Right? So let's do a couple examples here. Let's see. Okay, I've got our new textbook here that we're going to work on. Let's see if I can find a couple sample questions, because I think that's what people have been requesting, that I do a few sample examples. So let's try one of these. Okay. Okay, let's try question 3. So let me just copy this, and we'll do a couple of these questions. So take screenshot, that looks good, and I'll copy it. There we go. Go back to our notes, and here I'll paste it in here. Paste. All right. So in the interest of time, and to give us a little bit of time to work, I'm going to do a couple of these questions. I might try a different one as well, and then I'm going to give us some time to work in class on these exercises. Okay. Also, if you have any questions about any of the other homework that I've assigned previously, then we can work on those as well. Okay. So we're going to describe using mapping notation how the graphs of the following functions can be obtained from the graph y equals f of x. Okay. So this is the same kind of thing over here. So this is what I would refer to as the mapping notation. So I believe that we went over mapping notation sometime last week. Mapping notation is where you're saying, okay, where do all my points go? Okay, so if this is my point x comma y, where does x y go? Okay, so this would be the example of mapping notation. Okay, so let's see what would happen to the point, let's try this one. So let's try A. I guess I don't have to circle it. So I've got my point x comma y, and I want to know where does x comma y go. And it is actually traditional to put a little stopper on one end of your arrow, but you don't have to do that. But you might see me write a little stopper at the end of my arrow. Okay. So I want to find where this point x comma y goes. So what kind of shift have we done? Have we done a vertical shift or a horizontal shift here? Yeah, we've done a horizontal. In which direction are we going? Yeah, we're going left, right? Because it's a positive value. We need to know what we're subtracting. So the horizontal shift is going to be left by 10. So that means that we're going to subtract 10 from our x value, and our y value is going to stay the same because nothing has changed in our y values. So in other words, if we wanted to know, let's say that this is my point x comma y. My horizontal shift is to the left by 10 units. So my y value here is going to be somewhere over here. Sorry, not my y value. My translated value is going to be over here, and that's going to be, well, I shifted my 10 or my x over by 10 to the left, and the y stays the same. So that's how we would sort of conceptualize that one. Okay. I'm not gonna do all of these because I would like you to try some of them. But let's try the second one actually. I would like to try this one. So I've got okay, so this one, it looks a little bit different. So I've got y plus 6 is equal to f of x. Well, this is not exactly how we graph things, right? When we graph something, we want our function to be y equals f of x. That's what it means to graph something, right? So the idea here is that we're going to isolate y. So we're going to get y is equal to f of x minus 6. So I've gone ahead and done that, and now I think it should be fairly clear sort of what kind of mapping this is. So I'm going to take my point x comma y. I'm going to bring that to, well, I'm going to bring it exactly 6 units down. So this is going to bring me to the value, or the point x comma y minus 6. Okay. Any questions about that? No. Okay. Let me do one more example. Let's do. Let's try this one. Let's try number 4. Okay, take a little screenshot. That looks good. I'll copy it and go back here. Grade 12. Okay. Okay, I like these types of questions because we're actually going to be doing some sketching. Okay, so this is number 4. So let's sort of read this for a second. So I've got the graph y is equal to f of x. That's this graph right here. Okay, it says so right here. So y is equal to f of x. This is our function here. So I want to describe the transformation that can be applied to the graph of f of x to obtain the graph of the transformed function. Then write the transformation mapping or in mapping notation. Okay, so we have 2 things to do here. So one is to describe the transformation that can be applied to get this one. Okay, and then next I want to write the transformation using mapping notation. Okay, so let's try the first one. So let's try 4a. Okay, so this one here, so I've got so r of x is equal to f of x plus 4 minus 3. So to describe what's going on here, I'm going to say that, well, this corresponds to shifting left by 4, and this corresponds to shifting down by 3. Okay. Okay, so then the using mapping notation, the way I would write this one out is that x comma y is going to move to the next point over, which would be, well, I have to shift left by 4. So my x values are going to get 4 less. And I'm going to also shift down by 3. So my y values are going to become 3 less. Okay? Okay, are we ready to try some of these on our own? Yeah. Okay. So let me just copy some of these pages out, and I will tell you which ones I'd like you to do. So hold on just 1 second here. Gotta do this. Select these pages. 1, 2, 3. Okay, I'll copy those. I'll put them in here. Close. And then here I will paste pages. Beautiful, awesome. Okay, so yeah, this book is really nice. I think you're gonna like this book. It has a nice little summary at the end of each chapter that sort of has these key ideas. So I'll kind of highlight the questions I'd like you to try. I'm going to get you to do 1 and 2, 3, 4, and then 5. So that should keep you busy for the next day or so. I will assign a few more of these questions in the next couple of days. But those are the questions I'd like you to try for now. And yeah, so this is it. And yeah, okay, I'm gonna end the video now because I want to spend some more time with the folks who are in the classroom. And yeah, I'll post this on class in a minute. Okay.